Welcome back to the Wibbit.net Introduction to Programming tutorial. In this video, we're going to talk about flowcharts.
Hooray!
Yay! Now, one thing to keep in mind about flowchart, Brian, is they're very boring.
Yes.
There's nothing fun and exciting about making a flowchart.
Absolutely not.
No, and if you work in a job that requires you to do this with planning, and it's actually a really good idea whether you're required to or not, you're going to hate it, but when you get towards the end of the development life cycle, you're going to really love the fact that you took the time to plan your project.
And if you find yourself not using flowcharts, what you will find yourself doing is thinking in terms of flowcharts. So one of the things that's very important with flowcharts is something that's very intangible. Understanding flowcharts will change the way you think about programming. So it's crucially important to understand so that you can train your mind how to visualize a program. So even though you might not actually take the time to draw it out, you will take the time to think it out. It will become how you think of a program.
So as a basic definition, flowchart is a diagram that has predefined symbols and it represents a algorithm or a process. Now, some of you guys may have been exposed to many different types of flowcharts. Well, number one, not every single flowchart is the same because symbols are not standardized.
No.
And number two, flowcharts exist for other things besides software development. Mm-hmm. So you'll see many things expressed as flowcharts that are not going to be relevant to what we're going to be talking about.
Right.
Because we're going to gear this specifically for software programming.
And if you're not exposed to flowcharts, the most basic idea of a flowchart is traffic signs.
Okay, yeah, I can see that. Yeah.
So when you're driving, you use flowcharts all the time. You stop at a stop sign. You have a traffic light. It makes a decision, decides to turn green, which allows you to go on to the next step, which is the next road, and so on. Flowcharts are used all the time, but the way that we discuss flowcharts is just one view of flowcharts for software engineering. And in using these, you can define out the requirements of how a program will operate, how a program will make decisions, just like how we make decisions in traffic.
The first section of flowchart symbols that we're going to discuss are process operations. What we have on the left is a symbol with the text inside that is what it is. On the right, we're going to have the definition of what it is. Like we said before, these are not standard. The typical rectangle indicates a process or an action. What is that? What is that shape called? The curve?
Rounded cornered rectangle?
Sure.
A rectangle with rounded corners?
That works. That is a representation of a process that is an alternative to what may be considered a regular process.
Right. So a process is like a task or performing a task,
Mm-hmm.
an actionable thing to do.
Mm-hmm. The subroutine item or symbol represents an instruction that can be executed multiple times. Like we were talking about before about functions and methods,
right,
that would be expressed using these types of symbols.
So this is more process operations, including a preparation, manual operation, and delay. Preparation are measures that must be taken before defining a process. A manual operation, which you can see in the next symbol, is a process that cannot be automated. So it's something that requires human intervention.
Like, turn on your PC.
Right. And then this bullet shape is the delay, which depicts a waiting period. A lot of times a delay will either say delay or will represent some time value like 5 seconds.
And a lot of times you'll see preparation. Sometimes people will use this to store parameters arriving. So if I'm writing a flowchart for a function, my preparations are make sure that this function knows this, this, and this before you continue. So the next section we're going to talk about is flow. And some of the basic flow diagrams you see will say arrow. This goes over here. So the first one is just a solid line arrow, which indicates the direction or the flow of the flow chart, whereas the dotted arrow or the dotted line is typically used in comments or when showing an alternative process. Comments will not have the arrow at the end. Typically, a comment is dotted lines followed by a circle or a box that just has human readable text in there to explain a section of the flow chart. The reason why there's no arrow is because a comment is not part of a flow. It's just, hey, did you know this kind of thing. And when you're drawing a flow chart, any situation where you have lines crossing, it is standard to have a little loop
row bump
that shows that this one goes below this one. Because otherwise, if you don't have that, what that means is the flow goes up and continues on to this line.
or splits off into these two lines.
Exactly. So it's important that you have your little road crossing where your lines overlap.
Next is the terminator symbol. This is the beginning or an end of a sequence. Do this, this, and that, and then terminate. The next is a connector. It connects two sections of a flowchart. So if you have a flow that is grouped into logical segments or clusters, you can connect these with connectors.
Mm-hmm. And typically, when you have a connector, it'll say like 1 matches with 1, or it'll be labeled so that you know what it connects to.
Right. If the connectors go to another page and aren't just in another section of the diagram, then you'll have an off-page connector.
Well, it's like a home plate for like a baseball stadium. Yeah.
So the off-page connector says, see this connector label on the next page.
Yeah, or on page 5 or something like that. So continuing with flow, we have decisions. The flowchart representation of a decision is a diamond shape. And the reason why is you have one line that comes in with multiple ways to come out. Now, in a situation where you have, let's say, more than 3 decisions that can be made, you may have what's called a decision list. Now, a decision list is just a box that has little things on the bottom where the flow would then move from there. So each one of these boxes represents a potential decision to be made. Mm-hmm. So something comes into my decision, and I have 20 different ways that this can end up, and each one of those 20s goes somewhere else. And that's what the decision list represents. And lastly here, we have the cloud, which typically will represent things like networks, LANs, WANs, the internet, and whatnot. But Brian also mentioned earlier today, I didn't even think about this, but in some flow diagrams, the cloud will also represent something that you don't really need to know.
Right, that's too complicated to describe.
Right.
So just some mess of things that you don't need to understand. Mm-hmm. It goes into the mess of things, and something else comes out of that mess of things. That's basically what the internet is some
it's just a mess of things.
Indescribable mess of things.
Exactly.
So to wrap up the flow symbols, we have the merge and splitting out symbols. The merge looks like a funnel where you have multiple things coming in and only one thing coming out, or lesser things coming out. The opposite shape, which is if merge is more of a feminine symbol, this is more of a phallic symbol, is the splitting out. So it goes into the smaller end and goes out the wider end. Mm.
And that could be used in multiple contexts. I mean, you could take the literal usage, like if you're writing a program that says unzip these files, you could use this. But there's also like different ways of like taking 5 processes and converging them into one.
Right.
And taking, one process and converging it into many. It's used in many contexts.
Right. Or even like in a duplex, multiplex way like Prism. Mm-hmm. So you have many rays of light that go to white, many colors that go to white, and then white goes to many colors.
There is also some flows, structures, or symbols that do some form of operation. Like in this case, we have a summation junction. A summation junction simply just takes 2 values, 2 numbers. 2 numbers come in, 1 number comes out. That 1 number that comes out is the sum of the 2 numbers that came in.
Right.
And we also have logical things like an OR. So we have 2 inputs. A logical OR is the output. So 2 things go in, 1 thing comes out.
Mm-hmm. We also have other things like collation operations, which represents converting data from its input to a standardized form, or normalization operations. Mm-hmm. We also have the sort operation symbol, which is maybe a little more commonly used. So the sort operation indicates that you have a collection that comes in, and the result of which is a sorted version. Yep.
You couldn't have said it any simpler than that. So we're going to start talking about some input-output stuff as well. Data is represented by, what is that? What is rhombus? What is that called? I don't even know. I don't know what that symbol's called, but whatever that symbol's called.
Parallelogram?
Whatever. Okay, I'll buy it. That represents data that is either going to or coming from a process. So this is just data that's being stored. You put the values in here. This fun little sideways light bulb that is weird looking.
Pencil?
Yeah, okay, or that. That is displaying to the user. Now, typically, the display is monitor, but I've also seen this in the context of other output as well. Mm-hmm. Even though it's usually used in the monitor context, it can be used in others as well. And this weird-looking other thing, the manual input, sort of looks like a keyboard if the keyboard was broken. This usually indicates input from a keyboard or mouse or any other type of manual input that the user has to provide to the flow of the program.
It also reminds me of the shape of a sign from the 90s. Like, do you remember the restaurant from, like, Saved by the Bell?
Saved by the Bell, the Max.
Yeah, the Max's. Yeah. It has, like, that weird square behind it because it's got to be, like, all funky and neon.
Maybe they stole that from flowcharts.
They probably stole directly from Saved by the Bell. I think AC Slater is going to just destroy this flowchart.
Mario Lopez, yeah.
For those of you in India, definitely go to torrents and find...
Well, don't say torrents. That's not legal.
No, torrents of excitement.
Oh, okay.
And investigate time into finding some avenue of acquiring old Saved by the Bell episodes.
Yes. Some more about input-output. These are yours, or these, yeah.
All right. So these symbols represent a document and multi-documents. One of the reasons why these symbols are kind of important is a lot of times a program is the process of solving a real-world problem. And like real-world problems, you deal with documents and files, and those files and documents happen with the computer. So just like you'd say, this person takes this file goes into this process and comes out as this other document, just like in computers. You have documents in a lot of different forms. So document or a file or sometimes an object, it depends on the situation. A document can also be like an image or a video, but nonetheless, it's a document. And when you have a package of documents or multiple documents, you see them stacked on top together like this.
And, you would also see these in the same flow diagram when you have like a one-to-many document relationship, where you have like a PDF that splits into multiple pages.
Yep.
The input is one document, the output is multiple documents.
Absolutely.
Now we're going to talk about some storage. The first one we're going to talk about is internal storage, which in today's world pretty much means RAM. It may have meant something else many years ago, but that's pretty much the story we're sticking to. It indicates stuff that is stored in RAM. The next one is external storage. Now there is some kind of a little bit of fluff here, because there are so many different types of external storage. Why would you just want to have one symbol for all external storage? Typically external storage is represented as some sort of a disk shape. A lot of times the fatter the disk, the more that means hard disk. And the thinner the disk, or cylinder, the more that means database.
And sometimes the larger the symbol, the more data it can represent. If you see multiple external storage symbols next to each other, and one's very small and one's very large, sometimes that actually represents some sort of proportion of size and scale. It's also no coincidence that the internal storage symbol looks like a spreadsheet, and the external storage symbol looks like a database.
Yeah.
Or a series of spreadsheets. So,
or a disk, because, like hard disks that aren't solid state are literally disks stacked on top of each other.
So, but these symbols are more abstract forms. And sometimes flowcharts are used for different things. Sometimes flowcharts are just used to represent things very heavily oriented towards network diagrams, or database diagrams, or decision logic diagrams, or computer function diagrams. They are abstract, and you can apply them in a lot of different ways, but conceptually, this is internal and external storage.
And there is a little bit of a slight access, or slight momentum change here between external storage and direct access, which typically represents hard disk storage, but that's not always the case. Brian and I are more used to the external storage diagram, meaning disk space. Right. But the direct access can also represent that as well, which is the same thing, but it's sideways.
Yep. Lastly, we have the sequential access storage medium, like a magnetic tape reel or a tape backup. Usually you'll see these if you have an off-site tape backup process. So do these following actions split off the flow to an SAS symbol, and then have that SAS symbol delivered to the courier that takes it to an off-site backup, for example. Usually that's most commonly where you'll see this. The stored data symbol looks kind of like the direct access symbol, but without the top. And that represents generically a data storage operation, not the location of where data storage is stored, but the process of storing that data.